There are two very different ways to build a quantum computer, and the biggest names in the field did not all choose the same one. Google and IBM went one way. A smaller company called IonQ deliberately went the other. That single engineering choice, made years ago, before there was any revenue to defend it, quietly shapes almost everything about the company today. How fast its machines run, how hard they are to scale, and what would actually have to go right for the bet to pay off. So forget the stock price for a few minutes. Let's look at the one bet behind IonQ and why it cuts both ways. Start with the mechanism, because the rest follows from it. Most well-funded quantum efforts, Google, IBM, and others, use superconducting qubits, tiny electrical circuits printed on a chip and cooled to a hair above absolute zero, colder than deep space. IonQ took a different road. It traps individual atoms, charged atoms, called ions, suspends them in an electromagnetic field, and manipulates them with precisely tuned lasers. Think of it as the difference between fabricating a circuit and holding single atoms perfectly still with light. One is built, the other is captured, and that distinction is not cosmetic. It decides what each machine is good at and what each machine struggles with. Now the part the headlines usually get wrong. The race is almost always reported as a number. Who has the most qubits? But a qubit that makes errors constantly is close to useless, because the errors pile up faster than the computation can finish. So the metric that actually matters is not how many qubits you have. It is how reliable each operation is. That is called fidelity, and it is the real bottleneck for the entire industry. Here is IonQ's edge. Because its qubits are identical atoms, naturally stable, and able to connect to every other qubit directly, trapped ion machines have historically led on fidelity. On the number that matters most, IonQ chose the harder-to-fake advantage. But every bet has a bill, and this one is real. Holding atoms with lasers is exquisitely precise and slow. A trapped ion gate operation can take far longer than a superconducting one, sometimes by orders of magnitude. That means lower raw clock speed. Worse, you cannot simply keep cramming more ions into a single trap. Crowd them and control gets harder and noisier. Superconducting chips, by contrast, are built with the same kind of fabrication that scaled the entire semiconductor industry. So adding qubits is in principle more of a manufacturing problem. So IonQ leads on quality per qubit, but faces the steeper question: how do you ever get to thousands or millions of them? So, how does IonQ plan to escape that ceiling? Not with one giant trap, but by networking, linking many smaller, high-quality traps together using photons, particles of light, to carry quantum information between them. If that optical interconnect works at scale, the fidelity advantage compounds across a whole network. If it does not, the company stays stuck below the scale its thesis needs. That is the load-bearing bet. One more thing to know honestly, IonQ often reports its progress in algorithmic qubits, a usable, error-aware count rather than raw physical qubits. It is a reasonable idea, but it is also IonQ's own yardstick. So, it is worth comparing carefully against how rivals measure themselves before taking any single number at face value. So, what is the honest test? Not a prediction, a checklist. The architecture bet is testable, but on engineering, not on the ticker. Watch whether the optical interconnect actually links multiple traps at scale without throwing away the fidelity edge. That is the whole thesis in one milestone. Watch whether trapped ion gate speeds improve enough to stay competitive, and watch whether the algorithmic qubit numbers hold up when measured against rivals on equal terms. None of this is a forecast, and none of it is advice. It is a framework for one of the most interesting bets in deep tech, a company that chose quality over raw count and now has to prove it can scale. See the bet clearly, then verify everything yourself.